In this video, we talk about solids of revolution. Solids of revolution, George Washington, Sam Adams, they were pretty solid in the revolution. Oh, sorry, not that kind of solid of revolution. But what do we mean then by a solid of revolution? By that we mean a solid, so an object, that is formed by revolving a curve about an axis. So in other words, something that could be made on a lathe. Now forget about the fact I dropped this candlestick and broke part of it, but the idea is that a solid of revolution really is something that could be made on a lathe. So how do we have it? You have an axis of rotation through the middle, and then if you know the curve, the equation of the curve that's on top here, then that would tell you the radius of the circle at any particular value of x. So think again about the distance of the top of the curve from that axis of rotation. Alright, so how could we find a volume then? We already know from before that volume is the integral of the cross-sectional area. So again, A of x was the cross-sectional area. So that's something we discovered in a previous video. However, what are the cross sections here? The cross sections here are all circles, right? You have a circle. If it hadn't broken, it would be a circle. Here you've got your circle. All your cross sections in the middle are circles. And we know the area of a circle. The area of a circle is pi times the radius squared. So that means for a solid of revolution, volume would be integral from left to right, a to b, of pi times your radius squared dx. Because pi r squared is the area of the circle, that's your cross-sectional area then, and so this gives us then a formula for finding the volume of a solid of revolution. And in a few pen casts then, we will give several examples of how to use this particular formula for finding volumes of solids of revolution.